Hello everyone, welcome. I'm very happy you came for this presentation. And as it was already said, this presentation might probably somehow influence the way you look at programming. Hopefully, that's my goal. Actually, I came up with an alternative name for this presentation. Where I make it explicit that we'll be actually talking about the current state of programming and some alternative way of programming, and maybe discuss whether the way we do programming could be changed somehow. So take this more as an inspirational thing. I'm not saying that this MPS and the stuff I'll be showing here is something you can use tomorrow on your daily projects, but it might be something that can influence the way you think about programming, and maybe it will help you one day in not so distant future to create maybe domain-specific languages for some of your customers. I'll actually show you some practical examples how people use MPS already, which might also inspire you. Now, before I start, I'll just check before we started. Now, everyone here is probably too young to remember the days when programming was created, right? In 1950s and 60s, when those clever people invented programming. They built the foundations on which programming still stands. And when we were born, programming was already or had already been invented, and we just accepted it. And that's a natural way how human brain works. If something exists when you are born, you take it for granted, and it's difficult to question it and imagine the world, how it would look like if the thing was different or wasn't there. So the same with programming. It might be very difficult for us to imagine that programming could be actually done differently if it was invented today. Right? And this thing about brain not being able to show you clearly the state of the world, if knowing that some stuff was created and was there when you were born, this is called cognitive bias. And if you read books on psychology, you realize there's many of these biases that we suffer from. On Wikipedia, you can count them. There's more than 100 of them. I want to mention two in particular. There's one called brand loyalty bias. I always find it difficult to pronounce this. So brand loyalty bias. It is the feature of our brain that tries to, whenever you make a decision, you buy something, you agree with something, you go somewhere, then your brain tries to find rational reasons why you made that decision or why you made that choice. Because it's difficult for the brain to admit that you did something without any reason or based on emotional feelings. So always people tend to sort of rationalize their decision. So if you buy something, you kind of find rational reasons why this brand of mobile phone is better than the other brand of mobile phone, for example. And well, another bias that's even more important for what we'll be doing here is called confirmation bias. That's a bias that whatever you believe, your brain will filter incoming events or incoming ideas, but will filter them so that whatever confirms your belief will be accepted, and whatever challenges your belief will be diminished or ignored. So it's a natural sort of way how the brain works without you even knowing it, right? Your brain will just filter items so that you confirm what you already believe. There's actually, we've got tooling for this, right? To support our beliefs already. All these, social networks, they only emphasize a confirmation bias because you typically surround yourself at, Facebook or somewhere with people who have the same worldview, and then it might make you falsely believe that everyone in the world has the same set of priorities or the same set of beliefs. And today, because I want to challenge the way we do programming, I want to make sure you kind of suppress this confirmation bias for this presentation. Be sure that I might show you stuff that you might sort of find not mainstream and different from how you do things, and you might feel endangered in your beliefs. So please suppress that bias for now. And since this is the Lambda Meetup, you already are probably half the way, away from mainstream, and you search actively for alternatives, so it might not be a problem for you, I believe. So what I want to focus on here are tools called language workbenches. It's not only JetBrains MPS, there are other tools, and they all try to achieve a similar goal. They try to give developers the ability to easily create or modify languages. Well, essentially these tools have three capabilities. They allow you to create new languages, they allow you to modify languages that already exist, or you can combine languages together at will, if it makes sense. I want to illustrate these in practical examples. So first, new languages. Here's one. Here's an example of a new language I created. It's actually inspired by a language called Karel. How many of you know Karel? Oh yeah, quite a lot of people. That's the language, right, that most people started programming with. So I decided to take that language as inspiration and implemented it in MPS so that I got full IDE support for that language. So now I can write code like this, which is a script for some robot that I can run. And it will create Java Swing application with a robot, and that robot will follow the script and walk around, the scene and, collect marks and so on. And, you get full support for this language just like in all JetBrains IDEs. So you get code completion for, the elements that are suitable at various positions. You get navigation, so if you are at a reference to some method, you can jump to definition of that method. You can rename that method and it will rename all the places where it's being used. You can search for usages, highlight usages. You can do refactorings, basically all the stuff you know from IDEs, but you can have it for your own language that you invent or that you copy from somewhere. And you can have these languages then either interpreted or you can generate them into some runnable code like Java and run them. So that's one thing that language workbenches can do for you. You can create new languages. Well, you can also take existing languages and modify them. So here is a piece of C code. Does anybody know C? Good. So this is a piece of C code. But in particular, this is a sample, obviously. But now imagine you were writing in C code, you were writing something like, whatever, some navigation system, right, where you have coordinates, X and Y. And then coordinates obviously have to be in some distance physical units, like, let's say, meters. Now, C has no support for meters. You just express that you want your position as two integers, X and Y. But the type system will allow you to combine two integers, even if they, if they contain different physical units. Like you can add kilograms and meters together because there's simply no distinction between kilograms and meters because both of them can be represented as integers. But you can extend language. So you can extend C with physical units. So now you can say, well, that X and Y must be in meters. So you pick meters, and now type system is able to tell you wherever you're manipulating incompatible physical units. Like here I'm comparing meters with non-meters. And if I mark it kilograms, now it becomes obvious, right? Now I have meters and kilograms, obviously has no meaning to compare these two. While if I say that this is meters, then yeah, it makes sense and the type system becomes happy. So you can declare your variables, your parameters, your return types. You can annotate them with the required physical unit, and that will help the type system to make sure that your code is valid even in the physical unit sort of side of things. Well, the third thing is that you can combine languages together. Here's an example. Java. Here we go. So this is a Java class, but you notice there is some non-Java code here, some table. What we call this decision table because it is used to, depending on which column and which row return true, then it will make a decision what return value there will be. So this table will return, one of these 4 strings depending on, which of these row and columns are true. And that will become the value of that variable I'm declaring here. So I'm declaring a variable, but the value of it depends on, this table, decision table. So instead of having nested if-else statements, then I can write it in this, some more intuitive way in a tabular notation. Or I can have a language that allows me to represent monetary values in a more intuitive way. So like 30 euro, right? So I can type 30 euro plus $10, and I could store it in a variable. So I could operate money this way, and I don't really have to care about how it's represented on the bottom line Java level, the way that normally you would in Java create some new money class and then pass in. I can't even do it here, and then you would pass in the 30 and euro as arguments. So I've got now sort of better looking representation of this. But the important thing, I can combine this together. So even if I have two different language authors, one that created support for these monetary values and another one that created support for these tables, I can combine them in my Java code together. So I can have a decision table that makes decision, and depending on which row and column is true, it will calculate some monetary value and return it back. And not necessarily have these languages have to be created by the same author. I can just grab them from the internet, download, put them in my Workbench, and I have them and combine them. Now, I'll show you how this is implemented, right, how this is possible, but we'll get to it gradually. So, let's look briefly at those 1950s and 60s, how programming actually was invented. Right, it all started with punch cards, as our dads told us when we started programming. So there were these cards on which you punched the characters that you wanted to feed to your computer. Then later, and this is what I already remember, there were these terminals, computer terminals. So keyboard with a screen and some long wire connected that device with a computer that was somewhere in the building or in the next building somewhere else. And you type characters, and those characters were sent over the long wire to the computer. So this is where the textual processing started. And so when you did programming, you typed characters, and you were in some sort of editor. You were editing text, and that text was fed to the compiler for compilation. And it was inherently a sequential process because the terminal was a sequential device. Then later, with personal computers, the editors became more powerful. But the principle stayed the same. We were editing text, and that text was then fed to the compiler for compilation. And well, and today's IDEs got pretty far from what the early editors could do, right? So now, when you manipulate text or manipulate code, it no longer resembles textual processing. It's kind of more high-level approach. I want to illustrate that in a short example to give you an idea of what I have in mind. Here we go. So I'll write a simple piece of code here, very simple algorithm. Some of you might know it. It's called sleep sort. Anybody know sleep sort? One person knows sleep sort. Second person knows sleep sort. Please don't spoil to the others, right? Because I think everybody should know sleep sort. So here we go. But the important thing is, the important thing is not the algorithm itself, but the way the piece of code gets created, because that kind of holds the idea I want to build on. So I need to. I should probably tell you more about the algorithm first, right? So the algorithm is a sorting algorithm, as the name suggests, sleep sort, and sorting integers. And you feed in integers through the command line as arguments, and it will print out the numbers sorted nicely. And it is a concurrent algorithm, so it will leverage the cores of multi-core hardware beautifully. So let's parse. Let's parse the argument. Restore its value. We might get an exception here. We need to print this. I said this is a multi-threaded algorithm, so we need a thread pool. should we create it up here? We should shut it down there. And well, now the important thing now, since it is called sleep sort, we need to call sleep here, which might raise an exception. Good, and now we need to make this runnable, I believe. And we need to submit that runnable to the pool. So let's see if it does the job. Oh yeah, I had them all nicely sorted. Did you get the algorithm, by the way? You did. Oh. So please don't use this in production. We don't use this in... sorry?
But this one here, it can be pretty optimized and cache more cache.
You mean caching what?
If you first deploy this in production and then you improve it, you will get more cache. Yes.
Yeah.
It is all IBM strategy.
Mm-hmm. Yeah, okay. Yeah, so maybe that can be used after all, right? Yeah, so, but obviously the algorithm wasn't the point of this, right? The point was how the code was created. You know, it was far from coding sequentially, left to right, top to bottom, just, you know, typing characters. In fact, I typed very little of the text that you see on the screen. I typed, you know, just, you know, the values somewhere, like, you know, well, like the name of the variable. Yeah, that's what I've done. And most of the time, I was just indicating to the IDE through some shortcuts what change I want to do to the code that is already there. And I wasn't thinking about this in terms of characters and lines and words, but in terms of if statement, for loop, you know, runnable, method call, method declaration. So, you know, the things I had in my head were different from, you know, characters, far away from, you know, the character level. So the overall process of programming, right? If you know, I wanted to create some sort of diagram that would illustrate the way programs get created. So yeah, you've got some model in your head, thinking about the problem, and then you have to kind of, through an IDE, typically you represent it in text, and as soon as you type something, the IDE will reparse it and will build some data structure here to represent the code. And that is the data structure on which the IDE will work and do the refactorings and you know, code analysis and all that. And then if you save your code, then you get some text file on disk, and you can invoke the compiler to read that text, build the AST, the data structure that is, you know, very close to what the IDE had already in memory before. And the compiler will then transform that tree gradually into something that is then flushed into binary format. So this is the schema of how programming is currently done. I want to spend a few words discussing the data structure here and here as well. Some of you might know what abstract syntax tree means. Who knows what abstract syntax tree means? All right, quite a few people here. Perfect. So, very briefly, what abstract syntax tree is. Right? Abstract syntax tree is a way to represent code, because code essentially is a tree structure. You know, Lisp, one of the oldest languages, had this already implicitly, even in the textual representation, right? So you type something like, well, you know Clojure after all, right? So you type stuff like this, so you can see the tree structure from this directly. But this is, you know, how that piece of code will be represented in memory of the compiler or interpreter. So it would have plus, that has 2 children, for multiplication of 2 and 3, and for the value 4. So that will be kind of map between the textual form and the AST. Now, if you start learning programming today, there are tools that are graphical that allow you to build your programs from graphical components that you drag with mouse on canvas and then build programs from them. And here it is more visible, even more visible than in Lisp, you know, that this is really a tree structure, it's a hierarchy. So you've got like this repetition thing, which has condition in there, which has some variable reference and some value. So So you see it's going down the tree structure, right? And then the repeat has some, body with statements. And you build that all with components that are lying on a palette from where you drag them to your canvas. And then you just fill in the blanks. You fill in the value here and there, which makes it very similar to how I did my Java programming. Instead of dragging components with mouse, I typed some shortcuts for the IDE to build them. And then I filled in the name of the variable, the value, the message to the user. So it's very similar to what I've done in IntelliJ IDEA. And if you look at a piece of code, let's say Java, thanks to indentation, you can visualize this tree structure behind. So you can see that if statement has some, statements inside, and then there's for loop which has some body with statements inside, so the hierarchy is growing. Some tools can visualize that for you, so you can see the actual AST behind the scenes for the code that you see in the editor. So schematically, your program consists of nodes. Each node represents some part of your program, like an if statement. An if statement typically has 2 or 3 children, one for condition, which is some sort of expression, one for the positive branch, and one for the negative branch. So it might have 3 children. And this is how the hierarchy is built. Well, in addition to that, you can have references. So if you call a method, or if you refer to a variable, you need a pointer somewhere else in the tree structure. Or maybe pointing to another tree if you're calling a method from another class, right? Here you have a class, here's a method defined, and here you're calling it, so you have a reference there, so that the compiler or the IDE knows what method you're calling. So it needs, a memory pointer to that place. Now, languages, if you look at languages then, because now so far we've been talking about programs, but languages are, this is the palette of components you can use in your programs. So in Scratch, it's really a palette. In Java, it's a sort of virtual palette of all the keywords, all the constructs that Java gives you, or any other programming language. So that will be some sort of palette of stuff that you can put in your code. And extending a language then means just adding new stuff to the palette. It's as easy as that. Well, and defining an element of that you can use in your language, it's also very straightforward. In Scratch, if statement is defined as this yellow shape with a hole for condition and 2 holes for positive and negative branch. In Java, this is groovy compiler, an if statement in your code is represented as an instance of an if statement class. That class has 3 fields, one for the condition, one for the positive branch, and one for the negative branch. Well, and in language workbenches, I'll show you an example from MPS. If you want to define an if statement for your language, like I did for that robot example, we do it in an object-oriented way as well, although we devised slightly more verbose language than Java. So if you want to define an if statement, you say, well, I want to define a concept called if statement, and it has 3 children, one for condition, one for true branch, one for false branch. And again, it can extend some other class just like in any other object-oriented way language. So you can refer to some other already existing concept and say that you're just specialization of that guy. I mean, is it understandable? I accept questions anytime, right? Feel free to ask them. Yeah, okay, perfect.
Yeah, that was good, but only when you have similar execution models for languages of different levels.
Mm-hmm.
What if they're different?
What if there's...
in Java and Scratch, how's it called? They're both imperative and quite similar in sense.
Right.
So you can easily combine them, but if they are different.
No, okay, you mean...
If you wanted to create Haskell in Java or in mobile versa.
Yeah, sure. If you wanted to create Haskell, for example, right.
Using this mechanism of
Yeah. Yeah, sure. Yeah, you can. Actually, I've got a guy that I meet tomorrow who's doing diploma thesis, Frege implementation. Frege is like the Haskell in Java thing. And he's doing implementation in MPS, right? So, I mean, there is no... this is the object-oriented way in which you define language. But you can define a function language using, these principles. mean, there's nothing that really prevents you from doing so.
Ultimately, yes,
Yeah.
because the Haskell compiler is somehow written in C or something probably, so some part of that. So
Mm-hmm.
perhaps, if I understand it correctly, the question is that you can combine the languages formally, but you still have to provide the semantics for the combination, and this is sort of a second step you have to do. So it almost looks like that you just combine the palettes, but it's just the first step, and then you have to do some more work to make it work together. It's not just like one thing.
Yeah.
But you can evaluate it. It would be evaluated later or something, or yes, but you have to specify that. In addition, define.
Yes, that's right.
You can do this. So the first step is that you combine the concepts, and then you will have to provide the semantics for the new combination. This is something that's only.
Currently, yes. Currently, we're talking about syntax. We gradually get into semantics as well, but this will take a while. Yes. You can't wait, right, for semantics. Yes. Yeah. So far, we're really concerned about, how it would look like when the user edits it. So what components do they have to really edit the code? So you would have, if you were doing Haskell, then you would have different concepts. You wouldn't have an if statement, obviously, but you would have different ones, right? You would have completely different statements to model, whatever the user will actually see on the screen. The tree, the components out of which the user can model Haskell code, but the Haskell code will again be some sort of tree. So yeah, a few more examples on this. Money literal, I showed you before, that thing, 10 euro, so that could be defined as some sort of expression. If you want to extend, well, in this case Java, but you could extend any other language that has expressions. So you would say, well, I've got my new expression that contains an integer, which is amount, and then refers to some other thing called concurrency unit. So you can, currency unit, where I can define stuff like Euro, USD, and so on. Or again, back to the robot example, repeat. Repeat would be again some sort of command I can give to the robot, and specify how many times I want to repeat stuff, and then the body, which is a list of other commands that should execute repetitively, a count number of times. So this is really defining the concepts out of which you can build the tree. So this is concerned about defining these elements out of which you can build the tree. But I'm still not saying what should happen when I want to run it. Right? So only how to build what the components are of that tree. Okay, so back to the schema, because that's enough about understanding the tree structure. So we're editing this text, and the ID will have to reparse it and save as text, and and then the compiler will repeat the process. Now back to 1950s. The things have changed since then. Right? Obviously there are many. The hardware is different. We do different types of applications than they did back then. We've got much more knowledge accumulated over years, and we've got new types of devices. I had a guy recently contacted me that he's experimenting with voice recognition for programming, which is kind of interesting idea. He said, if programmers don't have to sit at a keyboard all day long, but they can stand up and talk to the computer and create programs this way, wouldn't that be better? So it's an interesting idea. He didn't do anything, that could be shown so far, but definitely it's an idea. The voice recognition has made has been improved quite a lot. So why not? I had another guy telling me that he's experimenting with actually gestures to control computers and to potentially write code. So could we write code by combining voice recognition and some gestures? Maybe we could. So, but that definitely cannot be done in the old way of programming, where the computer expects text to be typed on a keyboard. So, what if really things change and we have to think about different approaches to programming? What if we're just stuck now in local optimum? We've been building this way we do programming. Now we got to a point where there's no really point in gradual improvements because there's nowhere we can improve. Maybe we just need to go down a little bit and try to find and climb a different mountain. maybe that now is the good time to start searching for a better optimum. And obviously things will get worse before we get there, right? So the path that we find might not feel as natural, as productive as the ideas we currently use, but ultimately we might get to a better situation where programming is more intuitive and more efficient. Or what if the view of programming we currently have is just too narrow? And what if there are other areas which could be called programming, but aren't at the moment because the tooling just doesn't allow the people in those domains to actually do programming? So, these are all ideas we had when we were building MPS. And you can't really change things unless you have people who are not happy with the current situation. So we had to search for discontent people who need to see some change and that would appreciate tools like language workbenches. And we found them. So here's a few examples of what we found. So a company in Germany, first example, finance company, I think it's insurance company or something. And, well, they've got a team of domain experts who understand finance. And, well, they have to write some rules for the finance operations they have. And they do it in an IDE called Microsoft Word. Has anybody ever did some coding in Microsoft Word? No one? Good, lucky you. So they have to use Microsoft Word with some formatting to describe some business level function. And it is really a function, right? It has a name, it has some return type, right? It has parameters, it has, well, documentation. So even more documentation than we typically do in Java. And they've got body, where there is really some code that describes, how these parameters should be combined into some return value. Well, once they have these documents, they save them as PDF. They send them to India. Right? And then they have people in India, programmers, who take these PDFs and now code them in C. And once they do that, they send them back to Germany to actually add them to the system. Now, surprisingly, code doesn't really work first time, typically. So they have to debug. So then they have to, in Germany, they have to take the code they receive from India, the PDF, and compare and fix and debug. And sometimes the trouble is you have different version of PDF and different version of that C code. So there are a lot of troubles there. So obviously these guys were looking for something better. So that's exactly what we were looking for, right? So we found them and we provided a solution. So here's Language Workbench. You can do the same syntax. So you've got code that looks similarly, but now you have all the IDE bells and whistles. So you have code completion. You have navigation between items. You have error highlighting. So if something is wrong, it's red. Or you can have yellow, like suggestions for fixes in that code. Right, so you've got code completion. You can have math notation. And you have a palette of things that you can use. Because if you're a domain expert, you're not really a programmer, so you don't really remember all the elements that you can use. So you might benefit from some visual palette where you can just click and have that item inserted for you. So they're using this pretty happily. Now, obviously, they don't have to send anything to India now, because they just hit compile and this will translate automatically into C code. And since they can store it in Git, there's no problem with versioning. These guys had never heard about Subversion or Git before. Now, they can happily use it. Although they are not programmers, they will happily use Git if, it makes their life easier. So now, all right, yeah? I'll show you in a few minutes. Yeah, obviously. Yeah, you have to, right? Yes. And if I forget, then please remind me, right? But hopefully I won't, because I wanted to show that. Okay, here's a second example. Before I say what this is, has anybody ever driven a proper truck? A big truck? No? These trucks, they have a device called tachograph. So it's some device that monitors, how fast and how far the track goes, and it reports to the driver when to make brakes. Now, it seems like a simple device, but the rules are not so simple. You've got different countries with different legislation, And you have different types of breaks. You might break in a, stop in a traffic jam, which is not really taking a break. You might stop on a ferry when you travel across, the sea. Then this is a break. So you have to express these rules, and then you have to encode them in a C, and upload them to the device. Now, again, this company who creates these tachographs, they have two teams: a team of business modelers who know the legislation and who use Microsoft Excel, well, another IDE, right? So this time tabular notation. So they express the rules in tables in Excel, and then they hand them over to the C programmers who encode them in C. So again, potential for errors and sort of long turnaround for changes. So again, they benefit from tabular notations in a language workbench, where they can feed it directly in a tabular notation that they are used to, but then when they hit compile, it will generate C code, which they can then compile and put on the devices easily. Well, and the third and last example, medicine software on mobile phones. Now, the idea is that there are certain diseases which require very expensive treatment, like cancer or diabetes. So you have to, the patients, they have to take medicine that's very expensive and has very strong side effects. So it has to be really measured properly. The dose has to be measured properly, typically by a doctor, to give to the patient. But then the patient would have to stay in hospital, and it's better for the patient if they can stay at home. So the idea is to give them a mobile application that can monitor their health through some wearables. It can monitor the blood pressure, the amount of sleep they had, the food they ate. So you can code like what you've eaten, right? So that the application knows about anything that's relevant, and it can calculate the proper time and dose of the medicine you should take at a certain moment. Now, the trouble is that if you want to create such applications, it's not enough to know, Android and do it in Java. You really have to have the knowledge that only doctors have. So you have to be a doctor to write the application first. Well, and second, the application has to be certified by the same authority that certifies the medicine itself. So you have to have some government agency that does the certification where they have doctors, and these doctors have to verify that the code you've written is really correct, and then the rules that you've encoded properly calculate the doses. So you can't really do that in Java or C programming. You need some high-level language that stays high level even when the application is written, because you have to hand it over, and you have to guarantee that the application that gets generated from this is correct. It does, there's no bug there that can cause harm. So again, they are at the stage currently of evaluating a language workbench to achieve that. So they would have higher level notations which doctors can understand, and they can guarantee that the generated code matches the code that you actually implement in those rules. Okay, well, these were 3 examples, because I think 3 is a good number. But there are many more customers we currently have that are at different stages of using MPS or evaluating MPS. So yes, this is very nice to see, the number of these grow every year. And surprisingly, none of them uses it for mainstream programming. It's really that these guys use MPS for some sort of domains that are off the mainstream of programming. So they do it for medicine software, or for finance software, or for engineering industry. So these are clearly domains that currently don't have proper tooling and benefit from tools that give them the same capabilities that we have, like version control or continuous integration. This is something unheard of in many of these domains. And now, thanks to workbenches, they can have that. Okay, so probably now it's a good time to explain how JetBrains MPS does things, because different workbenches do things in different ways. So let's go deeper into how we do it in MPS and how we can allow the notations that I've shown you so far. Well, one of the things that we focused on is this part, the editing part. When you edit code, we decided that manipulating, you have a model in your head, you have a model in the computer memory. Why do we need that bottleneck here, that textual thing where you have to encode everything in ASCII symbols only for the IDE to parse it to build that tree? And then again for the compiler to parse it. So obviously, this is the important data structure, not this one. So maybe we can eliminate this. So in MPS, and that's the core of projectional editing, or structured editing as it's called sometimes, That's an idea from 1970s, so it's not our idea. It's just that MPS implemented it, hopefully, in a way that is intuitive for the user to use. So with projectional editing, you actually directly manipulate that AST. So you're not typing text that the IDE would reparse, you directly change things in the AST. And when you hit save, it will save the AST. Well, technically, typically it's an XML document, could be some binary format, whatever you like, so some sort of hierarchy. So save it in that way. Well, and then when you decide to compile, you first need to generate something that compiler can compile. So in order to be able to use legacy compilers, we generate text, and the compiler will reparse it. But this is no longer a problem, right? This doesn't really, that isn't a bottleneck for the user, so that's fine. But ultimately, we could just pass the AST directly to the compiler for compilation. That's also an option to do. So as I said, when you type code in the editor, you're essentially manipulating AST directly. Well, I'll do that here. So if well, here's some piece of Java class, but in MPS. And this is really a projectional editor. Although it might look like text, it actually isn't text. So when I create a variable, I equals 1, now what you see here on the screen, although it looks like a text, it just sort of, well, it's an illusion of text, or it's a projection. The actual source code is a tree structure in the background, which I can visualize down here, with a very small font, which you probably can't read. And unfortunately, I don't know how to increase that font. That's why, otherwise I would increase it for you. But down here, you see the actual tree. So we see that what I've highlighted is a local variable declaration, which has an initializer, which is an integer constant, and that integer constant has a property value of value 1. So this is the tree I was talking about, right? This is the AST. This is the tree that represents this piece of code. And if I start changing, if I keep typing here, so back to IntelliJ IDEA. In IntelliJ IDEA, integer a equals 1, semicolon. So the same situation, I type plus, the character plus is entered, and the ID will reparse and build the AST. In MPS, I type plus, and it's sort of taken as a command to the editor. Hey, I want to change the AST somehow. So I type plus. Well, the IDE is not still sure what you want to do, so it's in red. So I add 2, and now it knows. I see. So you want to actually change the tree from just 1 into plus 1 and 2, right? So the tree has changed from just one integer constant into plus with 2 children, 1 and 2. And I can actually visualize this piece of AST, only the initializer. So now it is a plus. The right child is value 2, the left child is value 1. And I can keep typing. I can do, times 3, for example. So it will again reshuffle the tree, because now it needed to be rebalanced based on priorities. So the root is plus, the right child is multiplication of 2 and 3, and the left child is 1, and so on and so forth. So basically, now this went, even when I was doing this little example in IntelliJ IDEA, I was actually commanding the IDE what I want to change in my code. Now in MPS, you actually have no other way. Whatever you type is a command to the IDE, I want to change AST in some way or another. While in IntelliJ IDEA, you can still freely type text if you like, and that sometimes is useful, right? I'm not saying that it isn't. Especially for general purpose programming, you very frequently need to really manipulate that on textual level. It makes you more powerful at certain situations. Well, in projectional editor, you don't have actually that capability. You only can manipulate the tree indirectly through these commands. You never can access it on the character level, which might be a limitation for mainstream programming. but it's very minor limitation for domain experts and domain-specific languages. Was that a question?
Yeah,
sure.
I'd like to ask, what would happen if you added some number to the second child of the product? So it's applied to the...
Sorry, to this one?
Yes.
So if I edit...
So I expect that if you added some number, it would insert parentheses for you around the 3, and you know what I mean?
No, not really.
It depends whether it's transformation is applied to the whole chunk 2 times 3, or whether it's applied to just 3. So it's not clear which of those 2 possible transformations.
It's asking if priorities are respected if you type plus. Okay.
You mean like if I type +4?
Yes.
Yeah, then it will reshuffle the whole tree.
Yeah, but there are 2 possibilities how to do that.
Okay, well, the one possibility that is currently implemented would be that the top would be plus of the rightmost plus, right? So it would be, this would be the root, and this plus would become the new root of the whole tree. 4 on the right side, and then this plus would be the left child of this plus. So this is the top node, this is the child of it, and this is the child of this plus, and this would be the other child. This would be the child of this plus. You can actually visualize this by block selection. That is also in other IDEs. You can do the selecting the piece of code by climbing up the tree. So if I start from 2 and do increase selection, I get multiplication. Now I get this 1 plus, and then I get this whole thing.
Okay, so I'll ask after the.
Yeah. Okay. That might be a little bit more involved. What you want to say, right?
Yes.
Yeah. And we made it even so clever that you can put parentheses there, wherever you want, and it will reshuffle again. So if you add parentheses there, which is really across the tree boundaries, it will reshuffle that tree as well. So now the tree is reorganized to be done this way.
So it tries to mimic the textual workflow.
Right.
But in the core it isn't.
Right,
It tries
exactly.
to be as user-friendly in that respect as
Yes,
possible.
because that was the biggest obstacle to adoption of projectional editing in the 1980s, right, 70s and 80s when it was invented. Because the editors at those times insisted that you had to type stuff on, in tree-like manner. So you had to say, well, I'll be doing some adding on the left side. I'll be doing multiplication. I'll be multiplying 1 and 2 and add 3 to it, right? So you really had to go this textual in a tree-like, which is not very convenient. You can always, in MPS, you can always decide you want to see the tree. So we can switch this. So instead of seeing the normal expression, you can visualize it as a tree. So it's a plus expression of 3 and 1 times 2. This 1 times 2, so I might also want to see it as a tree. So please show it. Okay, so that's multiplication expression of 1 and 2. So now I have the tree right there in the editor. So that would resemble the old style projectional editing. This would be the programming if you had no text, if we were not trying to mimic textual behavior. Right, well, and thanks to this detachment between the abstract syntax tree in the background and then some projection on the screen, you get quite considerable benefits, which are very useful, especially for domain-specific languages. I'm not saying they are really valuable for mainstream programming, although they might be. But but then the downside of changing the whole tool chain and getting used to different editor is probably way too much pain. But for domain experts or the specific areas that I mentioned earlier, this is great benefit for very little cost. So they appreciate those rich syntaxes where you can have tables and money literals and all these non-traditional notations. So you can have tables, right? Tables like in Excel where you have values, some coefficient somewhere. Or you can have table to represent state machines. So you can have, like, I think I have it here. Here, state machine. So you can have If what you're implementing is some state machine that will eventually be some C code run in some robot or some controller unit, then you can do it really in some tabular notation where you feed in, the transitions between states, what should happen when some event arrives at certain state. You can write it in this tabular form, and you don't have to bother with the generated code that, on the C-level code, you would have to express that with a lot of if statements and managing the state somewhere in some variables. Oh, yeah. You mean slides? Yeah, here. One more? Yeah, all right. This one.
I want the default value in the right column of 0, 7. Can I do that? I say it's all 0, 7 except where I manually change it.
Yeah, sure. Yeah.
So I don't have to type the 20 lines of 0, 7, 0, 7.
Well, it's up to the language designer what they let you what you have to type. I mean, this is really. This is not semantics, right? So yeah, you might have some default value. You might have it somewhere up here, right? The default value is 0, 7, and you leave it empty here. If you leave it empty, then maybe the value that you type here would be used.
If I want like just a big chunk not to be the default value, but another value of the same for 5 rows, can I do this sort of things?
You mean like editing? So you select like these few lines and you say, no, all of them should be 1.2. Yeah. That's what you mean. Yeah, sure, you can do that. Yeah, just a matter of selection and then triggering the right action, intention. If the language author creates it for you, obviously. The language author has to provide you with some functionality to change that code, like refactorings, right? In Java, you've got refactorings like introduce variable or extract method. So you could provide those similar refactorings to this code as well. Right, you can have math notations, but proper math notations with the right symbols there. It's surprising how many people appreciate this simple thing, that you are able to express math in this way and then work with it as if it was a natural part of the language. So you can select it and you might introduce a variable that will just hold that thing, or you can extract a method to kind of be calculated this way. So it just becomes natural part of the language. So various kinds of positional notation. Yes, okay, go ahead.
Again, for this math notation, I don't know if you use LaTeX.
You mean?
How do you edit this?
How do you edit it? That's just.
Like Word where you have to point and click and it's a nightmare, or is it?
No. Okay, here's an example. So let's say I want to introduce summation. I want to add, so I type sum, control space, and I have it. Right, so I want to go n from 1 to whatever. Do we have something? We have, okay, 10. And what? Product or something. So hopefully, yeah, it should be usable from keyboard, right? That's the important thing.
I guess you tab between things.
Yeah, you tab between things, or you can use arrows as well. And also, but not in this example, but perhaps in this one, there's also a palette that you can really use for inserting stuff in your math in your programs. So let me go here.
Did you actually show this to researchers who spend their days writing horrible LaTeX code and what could do with such a graphical editor for formulas?
Yes, we did it. Well, not me, but yes, we tried. Those who listen and those who happen to be at a place where we demonstrate this, and yeah, they've seen it, and typically they express interest in this. So I was trying to show here we go. It's too small for you to see it, right? The editor in this resolution is not really nice, but I've got I've got this palette of all the functions that we support in this demo, which I can click and it will insert, so exponent, or what do we have here? Xt, yeah, x to n, and all the other functions. So that's another way to help the user, right? To use these graphical notations, because not everyone remembers the shorthand, the alias, like sum or product or others, to insert the stuff. So you can have this visual palette on the right side where you pick it from. All right, positional rotations, right? Those guys who were typing stuff in Microsoft Word, they can have similar notation, but in proper IDE. When you have people who are not really skilled professional programmers, they are scared of situations where when you give them, they start some programming and they give them, empty thing. And now you do your stuff, right? Now do programming, right? For us, that's fine. We know what to type, but they don't. So they prefer notations that guide them. So they hit, enter, and they see, okay, I've got circle, square, circle. Okay, circle needs these 4 things to enter, so I'll enter them. So I'm basically filling the form. So programming by filling the form can be useful to some type of domain users. Now, another advantage is if you detach the code, which is AST, from how it looks on the screen, is that you can have multiple ways to look at the same piece of code. So you can have here, let's say, very simple state machine in textual language, described now in textual language. So I've got 2 states, 2 possible events, and transitions. But I can look at the same code as a table. So now I'm seeing the same stuff, and I can now keep coding in this notation or in the structure, in the textual notation. So I can add another state. I can add another event, another transition, whatever, in text form. And if I switch to tabular, now obviously things are there, and I can continue coding in here. And now that was the question for version control of this. So yeah, let's look at version control. So I've made changes. I've added state. I've added an event. So I can open the changes view down here and see the changes. So now I see that I've added this state. I've added this event, and this is not text. This is AST. So this is XML. I can still visualize the diff. I can resolve merge conflicts. And I can even change the editor here. So if for some reason it's more intuitive for me to use the other notation for merging or resolving conflicts, then I can use it here. So if for some reason I prefer a table to resolve the differences, then I can do it.
May I have a question?
Yeah, sure.
How do we find the mapping between the textual notation and the tabular notation? Or are you going to show us?
Yes, yeah, I will. Yes. That's a very good question. We need to get to this. Right. Yes, because the way the AST, which is not visible here.
What are some other notations apart from the text and the table? We also set formulas. Do you have like a general graph, for example, or something?
Yes, you can do. Yeah, you can do diagrams like this, for example. Yeah, so you can do graphical things as well. So this is actually an example, again, of 3 different projections of the same AST. So there is AST representing components and dependencies. And you can do it textually, where you can say, well, I've got these components, and, well, this component depends on this other component. Or you can do it, well, this component depends on this component by adding plus in a table. Or you might just drag line or modify lines here, like this depends on that. Ultimately, the only limitation is whatever Java Swing can do, you can do, because these are all Java Swing canvases. So, you've got the AST, and the way you show it to the user, it's up to you. But obviously, we provide some ways to do it easily in some, for at least the typical notations, which we'll get to. So, and the last benefit I want to mention is the ability to combine notations or combine languages in the same piece of code, where you can have text and then, you know, some tabular notation here, some graph here, some hierarchy here, whatever you like. So, well, one example I like about this is, you know, this language that allows you to write requirements for systems. You know, creating requirements, typically people use Microsoft Word or some other tool to write, you know, big documents about what they want from the system. Now, one of our partners, they decided, no, we'll do it differently. We'll create a language for writing requirements right in the IDE in MPS. So they've got this, you know, textual-like text, where you language where you type your requirements like point 1, point 2, point 3, and you might write a lot of, you know, text there to explain what you want. But since you are in a programming language, you can declare some constants. You can insert references to code, and these references are live. So I can, you know, here's some reference to code which I click on, and I get to the real piece of code that it refers to. And if I change the name of this function, well, it will change in that requirements document or other type of documentation as well. So the documentation is live connected to the code which is supposed to implement it. And in functions, you can refer to the point in requirements that you implemented in that function. And if you want to be explicit, you can even insert a piece of code here to make your point in requirements. So here, this is some dummy requirements for some computer game where you fly with some airplane, whatever. So you, at some point 4, you want to be explicit, you know, how many points the player should get for flying at certain speed at certain altitude. So you can explicitly write that function. So in that system, I want there to be some function, that should be the name of it, should take altitude and speed as parameters, both integers, and this is the formula for calculating it. If the speed is this and altitude is this, well, this should be the number of points. And this is live code. This is not Microsoft Word where you just type some clumsy stuff, but this is real C code with code completion and all, you know, all the navigation that you would expect from editing C, including debugging. So you can start right there in the document. You can just debug, you know, these test cases where you type a few test cases, like for this altitude and this speed, you should be given this many points, and you can, you know, track it. You know, how the computation that you specified works for certain parameters. And we are still in the requirements document. Yeah, so we can nicely combine these notations. I think that's a very beautiful part of language workbenches. Now, yes, okay, so we eliminated parsing, which gives us these 3 benefits. You can use very powerful syntaxes, you can combine them, and you can use different notations for different things. One for coding, one for debugging, one for merge conflict resolution, for example. Okay, now we get to the editing and semantics stuff, because now we need to really show how this works inside. So now expect this to get a little bit, you know, denser, a little deeper. So far, I was limiting ourselves to the definition of a language being just the abstract syntax, the thing where we defined, you know, if statement should be this and repeat statement should be that. You know, these things, the concepts there. So like money literal should have amount and currency, or repeat should have number of iterations and some body. But that's obviously not all. You also have to define how it should look like to the user on the screen. In textual workbenches, you would define grammar for the parser to parse whatever the user types in. Well, in projectional editing, you have to define the mapping between, you know, let's say the money literal that we've defined, and, you know, how it should look like on the screen. And, you know, in MPS, you have a special language for this, which uses positional notation to express how you want things to be laid out on the screen. So for money literal, in this case, we say, well, we want a cell that will show the amount, the number of money, the amount of money. And this is bound to the, you know, to the amount property of that node. So whatever, if the user changes something in here, it will change the, here we go, this, right? This is the property in money literal, and then this is the mapping where we say, well, the amount should be shown here. And then next to it on the right side, there should be the name of the currency of that money literal. So you've got the amount, and then you've got the currency. You know, for repeat in the robot language, the layout is slightly different. I've got some word, some keyword repeat, then how many times, then again a keyword times, and then the body slightly indented, and then the end of the repeat, again a keyword there. And indicate should be some sort of layout that automatically takes care of situations where the line is too long, and stuff like that. So I have different types of layout managers I can employ here. If I want cells to be horizontally aligned, vertically aligned, or indented, basically you've got a line which stops somewhere, and if it's too long, it will wrap it automatically. Right, and then there's semantics. Well, in MPS you define semantics by creating a generator that will transform the AST into some runnable code. Typically Java, but you can choose different targets like C, JavaScript, C#, anything that you've got a good compiler or interpreter for. So, well, in the overall schema, this is the part. So you build your AST and now you want to run it. So now in order to connect to legacy compilers, you need to generate textual form. So you need some sort of generator that will ultimately, let's say we target Java, so ultimately it will generate Java source code, .java files. Well, for this to happen, well, we created our own version of Java called Mps Base Language, which is like a clone of Java, but defined using the MPS constructs. So we've got so in Java you have if statement. We have our own if statement, which is a copy of the one in Java, but defined in the MPS terms. So we've got an if statement. We have an editor for it, so that on the screen you've got if, condition, then you've got these braces, which can be on the same line or not, depending on whether the body is empty or not. And ultimately you've got a text transformation which will convert an if statement from the AST into an if statement in Java text file. So it will flush text into a text buffer, right? So there's like two text conversion where you've got a text buffer and you put there if, opening parentheses, then whatever the condition is, ending parentheses, opening brace, and then the body, and then you close it with there might be else as well, and then that's basically how you flush it into textual buffer. But that has been done. That work has been done. That's nothing to bother with if you do language design in MPS, because if you create your own languages or extensions, you typically target our clone of Java or some other clone of C code, right? The similar stack for C, similar stack for JavaScript, and there could be potentially for any other language. So you've got a clone of it, projectional one, defined in the Workbench, and then you build on top of this. And this is no longer textual transformation, but this is really AST transformation. So if you define your own constructs, which you want to translate into Java ultimately, you only define how they should be translated into the copy of Java, the base language. Yes, yeah, sure. Here's an example. The money literal, for example. Right? So you've got 10 euro, which is not valid in Java. So it's not valid in base language. So you have to translate AST that contains 10 euro into AST that contains something that is valid in Java. So perhaps new money and creating new instance of money, passing in 10 and euro in there. Now I'm simplifying. Obviously, this will not be one node, but perhaps like a couple nodes. This will be a little subtree that will get generated instead of this node. So this node has to be taken out, and instead you get like little subtree that would represent this thing. Well, to define it, you have to define, well, we use some like templating approach. So you define a template that for money literal, whenever there's money literal in the tree, I want to replace it with this piece of code, new money, and then some amount, some currency. That's what I want to take and put it there instead of money literal. And the actual amount, the actual currency, well, these are taken out from the money literal, so they're copied from here into here, and this is specified, well, down here. Here I say, well, take from this node, take the amount, and put it here. So not this value 1 here, but the real amount that is in the money literal. Let's try on, yeah, and this is not text notation, right? This is still AST, right? You can visualize that thing, the same thing that we have here. You can visualize it as an AST. So this is really AST to AST transformation. For the robots repeat statement, similar thing. In Java, well, the closest, semantically closest element would be for loop. So we'll change repeat into for loop, which will iterate from 0 into some value, which will copy from here into here. And we'll also copy the body from here into here. Right? So this value 2 will be copied into here, but we'll have this for loop there. Okay, so ultimately, this is the schema. But you can generate, obviously, multiple targets, not only one piece of code. Now, I don't know how we're doing on time, but maybe perhaps I could do an example, really practical, end-to-end, create some new construct, including, the definition of the AST, the editor, and the generator. Does it sound like a good idea? Yeah, good. Okay, let's do it this way. Range iterator. I'll introduce range iterator into Java. Let's say I want to add a new thing into Java that would be called range iterator. So, like simplified variant of a for loop. So I could type some expression like this many times repeat whatever is in the body. So very simple. Like repeat sort of loop. So in the broader context, you would have piece of Java code with variables and method calls, and you could insert this, this range iterator, iterate 20 times, whatever, do this. So in Java terms, how is Java defined in MPS? Each line ending with a semicolon is a statement. So even our range iterator will have to be a statement because we want to put it in bodies of methods. We don't want to put it in parameter list. We don't want to put it in class on class level next to field declaration, for example. No, we want this inside methods. So it's a statement because statement is inside methods. Well, the range iterator itself needs to have number of iterations, which is some value. So in Java, expression. So that's an expression. Well, in the body is again a list of statements, statement list. So we've got statements there. So that wraps it up. So it's a statement that has two children, expression and a statement list. So this will be the declaration. We'll create a new concept, range iterator, which is a statement and has two children, number of iterations, expression, and body, statement list. So I'll do it. So I'll use this existing language already. So here is the language definition. Right? So this yellow node represents a language definition. And for each language, you can define several things, like the abstract syntax that I'll be defining now, the mapping between the structure and what the user sees on the screen, the semantics in the generator, and then a lot of other things like refactorings, intentions, type system. We won't really bother with all of these. So let's start with creating a new concept. So range iterator will be a statement. We can give it an alias. I hope I probably gave it some name. Range iterator. So this is the default text that will be shown in the completion menu for this guy. Range iterator. And it should have two children, number of iterations and body. Should be expression and should be exactly 1. And then we have body, which is statement list, again, exactly 1. So I guess we've done this. So we have that concept, that abstract structure, the sort of the template for those nodes that you can put in your AST, right? The element for the palette. We have that. Now we need the mapping to the screen, so how the user should edit it. So we'll use the position layout to lay out the cells. So we have to lay out these two elements, this number of iteration and body, somehow on the screen so that the user can edit it. So let's use the traditional approach. So first we'll use the number of iterations. So first the number, then some keyword, perhaps times. We can use curly brace. And then that will be end of the line. So new line here. So the next cell will come on a new line where we put the body, and I would like to make it indented. And then we want the word, ending curly brace, and should go on new line as well. Now I could further style it here. So I could now make different cells look differently. Maybe this one could have some style that I have predefined called keyword. So this one should look like a keyword, maybe. This one could have some different styling. I could assign to different cells different styling, so they might be drawn in different font, different color, different size. What do you like? Basically, this is swing canvas that I'm filling with components. I could even just go wild and create some swing component here and create it by code. So I could just create some customized, highly customized swing component, like the math symbol, for example. Right? So this is how the math symbols are done. It's some image that's placed in a swing component in the editor. So now if I rebuild that language, it will prepare that language for usage. So now I can be using it in here, in my piece of Java code. So range iterator now appears in the code completion menu, but obviously only where it is applicable. It will not appear in completion menu here, because statements cannot be there, right? So range iterator, I want to repeat 10 times some system out print line. Hello world, maybe a couple times. Now, since this is an expression, I can add some, bigger computation here. Now, when I hit compile, if we look at the Java code that gets generated at the moment, here we go. So we get only empty Java class, empty main method, because there's no semantics defined for our range iterator. So there's nothing in the body of the method. So that's the next step that we have to do after defining the editor. And that is, these three things are essential. The abstract syntax to define the actual, the children and properties and references that a particular node can have, and the editor, how it should look like, how it should interact with the user. Well, now the last step we have to do in order to make it usable is to define semantics. So translate it into something that can be then converted into text for Java compiler. So here is the generator. And the generator defines a couple of reduction rules, which we call it reduction rules. It's basically the way how to translate a particular concept from your language into the target language. So we'll need to translate range iterator and now we'll be translating it into Java for loop because that's the closest thing. That's exactly the semantics we want. So for so this for loop is the thing that will be replacing the range iterator in the code. So let's start with this, just for loop as I've defined it here. So now if we go back to here and do preview generated text, this is what we get. So now generating this piece of code will result in a for loop inserted into the output, into the generated class, which is not what we want. We want to parameterize this, but it's close to it, right? We want a for loop that goes, but not 10 times, but in this case will be 10 plus 100, right? So it would go 110 times, and it would not print foo, but hello world. Okay, so that's just a matter of parameterization of this template. So this value 10 will in fact be replaced by the number of iterations. So the expression number of iterations will be pasted instead of this value 10. Well, and for this statement here, I think it's this way. So just replace it with the body of the range iterator. Let's see. Okay, so now the for loop contains the expression, how many times it should repeat, and the body of the body of the range iterator. Yes, sure.
If you go back to the thing that generates Java, I forgot the terminology.
You mean this template?
Yeah, this.
Oh yeah.
What means that 10 and the system don't print foo in the braces?
Yeah, these are just placeholders to kind of remind you, what.
Does it show them in the text editor then?
Yeah, it shows them in the editor, right? You would like not to see them there.
Oh, it's up to.
Yeah, we're still thinking about the best way to represent this, right? And yes, this is sort of. Yeah, we might actually decide to choose a more intuitive approach.
It's kind of confusing. I would be expecting the name of the parameter, the source, the number of repetitions, and the body.
Right. Yeah, that would be better. We're actually thinking about bringing, the stuff that's down here in somehow in here, and perhaps hiding the. Sorry. Yeah, it would probably be better because it is puzzling. Currently there's not much you can do about this. If I delete this, no, that's too aggressive. I can delete this. Well, I can leave that invalid. I think it would still work, but yeah, the language here shows you.
So what's the minimum thing that you can put in there instead of system of print line?
Yeah.
What if you just put there 0, let's say, instead of
This one.
Yeah.
Yeah, well, it has to be statement, right? So I'm not sure this will be valid. Well, it's underlined because it's not a statement. So we have to think about the shortest possible statement. Yeah, well, I think we can make even a shorter one. Let me try. Yeah, yeah. I think if I put just empty line, I think will do as well. Empty line is also a statement. Yeah. Yeah, well, even without one. I mean, in MPS Java, not in real Java. Real Java will just ignore empty line. But here, if I'm on an empty line, it is a statement, so I can wrap this here with body. Yeah, it should work this way. Yeah, I could do it this way. That's probably nicer. Let's see if it works. Yes, it does. Yeah, so I use empty line now. So yeah, but it's still there, right? The empty line is there. It's just not visible.
I have a question about the editor.
Yes, please.
Because you defined the abstract syntax tree now with the keyboard times, and then you inserted it with the control space or whatever. And you could write like the textual representation right in the editor, and Parser would understand it, or do you need to use the template?
Oh, I'm not really sure.
When you created the
Yeah.
model, you would just write the times keyword. Would it be recognized?
The times, not at the moment, because by default.
If you wrote an expression and then followed by the keyword.
Right. No, I would have to do something special about this. I could have it, right? But no, by default, it checks the alias that I have here, which I define to be range iterator. Yeah, I could change alias to times, and then it would recognize me typing times, or I can just times, right? And it would do it.
The original question was about right transformation, as I understood. We have not defined yet.
Yeah, that would be a task for right transformation. Yeah, that's like, you can define a handler. What should happen when the user types something, right? So you can define a handler that will create something for you.
So if you are on the integer constant and you type plus, notes you're creating.
Yeah, you want to create the integer constant plus and something else. Yes.
Yeah, because it seemed like magic.
Right. Yes. By default, the editor I've defined here is very static, right? It's just how to place components on the screen, and it has some default behavior which might work at least at the beginning, but at some point you might want to make it more fluent, more interactive, and in that case you have to define also the dynamic aspect of the editor, and that's exactly what you had in mind. You want to type times, and you want number of iteration to be created, or you might want to do stuff like 25 now times, and and to create that range iterator, and that can be done pretty easily, but you have to define it explicitly. Yeah, well, that's actually end of this demo. So you can ask as many questions as you like now, because we are at the end of what I have prepared for you. Right? I've got, obviously there are still limitations to what we have here. Right now, I can type expression like this, and the type system doesn't complain. Doesn't complain that I'm providing a string constant and saying, well, repeat times, whatever. So I would now have to define a type system rule where I would specify that the type of the range iterator number of iterations should be integer. I guess like this. So now it's complaining because I'm providing string where integer is expected. So now it's making sure that this is integer. So that's another aspect. Right? That's That's the type system aspect here, where you define various type system rules. Also, you might want to detect unreachable code, for example. So maybe you want to complain if there is 0 there. So if there is 0, you might want to highlight this as, never unreachable code, or you might want to indicate to the user that maybe 0 or negative value is not the right value there. What if you say -5 times? What should happen? Do you want some error here? Then yes, you have to define those as well. But you have the ability to do so.
Now, if you define a language like this, what can you do with it then? Can you export it as a plugin for IDEA, or can you generate some standalone program from it that the domain experts would be using? Or
Yeah, both.
how do you use it then in reality?
Yeah, that's a very good question. These guys from those other domains, they are very different from programmers in many ways. They feel overwhelmed if you give them like a tool like this, because there's too many menu entries they don't really understand. There are too many options, too many tool windows. So they prefer, a kind of reduced IDE that can only do the languages that you give them. And this is possible. You just take your languages and you package them as either a plugin for IntelliJ IDEA, but that would be again targeting programmers, or you package them as a standalone application that looks like all our IDEs but has only the menu items that are relevant and only supports the languages that you package. So yes, you can build Java IDE for domain experts that they can then use only for the languages that you package. We actually use it for, we've got a tool called UTrack, which is a bug tracker, and it has an administrative console, which is exactly an example of a tool written in MPS, where the administrator can define workflow rules, like what should happen if someone reports a bug for this particular subsystem, and nobody replies for 3 days, who should receive an email, and what should happen to the priority of that issue. So these type of rules are defined in a language that was created in MPS and then packaged as a Java application for the administrators. Yes, question there?
Have you thought of different representation of the text? Because I tried the UTrack editor 2 or 3 years ago. It's different right now, but I think it was possibly the worst programming experience I've ever had.
Now you mean...
I knew that I had to enter 3 lines long length of the program, total 3 lines, and I was fighting 20 minutes with that. And in the end, usually the easiest solution was to cut and paste the whole AST from somewhere else, because I was basically unable to enter it.
Now you mean...
It looks like a text, but it's actually the AST thing.
Yeah, so you mean the console, right?
Unable to enter it.
Yeah. So you mean the console, is that right? The UTrack console.
Yeah, it was the whole thing. I mean, you have to download something, you open the program for workflows.
Yes, that one. Right, yeah, so we're talking about the same thing. Right. I'm not sure I have it installed, actually. No, I don't. Yes, that the trouble with that thing is that it uses MPS from version, I think, 2 point something.
Yeah, it was very well done.
Yeah, and they actually now looking for a web-based solution, so they stopped evolving it. But you're right, the language they have there, they didn't really pay too much attention to the fluency of editing there. Yes, so it doesn't really give...
It works if you have the idea of the final thing, and you started to write a program from left to right, and completing everything.
Yeah, I see.
That's not the way I'm writing programs. I usually have some idea about the overall state, and write it from here, and write it from there, and that was totally the thing that cannot do at all.
Yeah.
Because it wouldn't fit its AST style, and on top of that, it's different in here, because we've shown us the 3 representation, but it wasn't there, so it looked like a plain text, but it was actually a 3.
It was,
and
yes.
you have to know that, okay, I have the caret here, and if I do this section, then I can then do this AST3 there, but it looks completely the same as it did without those directions, but in that case I couldn't enter the same text. So
Yeah. So you've actually
too much magic.
you've actually experienced the MPS editor like several years back, and that's this console is one of the tools that gave us a lesson on how languages should actually be designed. Because yes, you're very right. That language there, you had to really understand what you want to achieve, and then it would allow you to enter that. But if you wanted to evolve it in a non-traditional pattern, then it would not work. And yeah, the language design in that console wasn't very good. But obviously, it can be done. Like the base language, the Java thing, right? We do all the programming in MPS in this Java, the projectional one. So the editor can be done so that it is intuitive and fluent and allows for, for different approaches to how you manipulate code. Just the language designer has to spend more time designing the dynamic behavior of the editor, which these guys did not. Because then, at some point they stopped and decided to find a web-based solution that would allow the administrator just to log into the app console, not to have some Java application installed. Yes.
Maybe you could show us the console, the MPS console. It's a very interesting feature.
Oh yeah, so you know something about MPS, right? If you know that there's console there. Oh right. Yes, the console is a great thing. I'll actually switch to the robot example.
I used it once to do some refactoring.
Yeah.
And it was very nice.
It's actually a tool that you've got down here that allows you to manipulate programmatically your code. So you can, for example, find all instances of if statements. Let me check if it's the right. No, that's not the right one. I need the other if statement. Okay, no. Well, I learned to ignore those. So I need this language. No. This one. So I can, for example, find all if statements in my code. So I've got a list of all if statements that are in my program. I mean, not in this particular file, right? But in my whole project, in my whole program. So here's all the instances of if statements. Okay, good. I can find them. That's fine. But I can do more. I can find all instances of if statement where it dot body it's called true branch, I think. True branch, where the true branch commands is empty. So now it's searching for all if statements where the body, the true branch is empty. And yeah, let's do that. All right, so there's none. So let's make one somewhere. If wall ahead. Okay, so I've got now some if statement there, maybe some other if statement empty with empty body over there. So it found two nodes. Now obviously I can click and get them and navigate to them. But I can even change them. So let's say if I find if statements that have empty body, then you know what, I can delete them. I can delete them from the program. And they're gone, right? They're no longer there. And I can undo that change if I don't like it. So you can manipulate your program programmatically from the console. So you can navigate and you can change things. You know, you can, if you find an if statement that is empty, that has empty body, you can insert something into it, some comment maybe, like, you know.
It looks super cool. Now, imagine that I want to use it one time on my existing Java project, and I want to keep it as a plain Java project for, let's say, because whatever reasons.
Yeah.
Can I like import it into MPS, into your language model, then refactor it, and then export it back to the Java, so that it looks just like before only?
No, it wouldn't work, unfortunately. I mean, that, not out of the box. Especially if you wanted to get it back, right? You could import that Java code inside, because MPS comes with Java Parser, so it would be able to parse it and build the model. It actually does it, because if you have Java, you know, typically if you want to use it as part of, you know, existing Java code base, then the scenario when you keep your Java in Java and you do some other stuff in MPS, then this is supported, because MPS can parse your Java sources and make them available as models here, but read-only models. So you can refer to your Java classes from your code in MPS, but you cannot edit those plain Java files.
When I imported the comments, for example.
Sorry, that it comments. Well, from sources, I'm not sure it keeps the comments. Well, if you do it for classes, then obviously there's no chance to get the comments. Maybe, maybe for Java sources you could. I'm not sure. I would have to check. I mean, in principle, it would be possible, right? Because the comments are part of.
Java sources.
Yeah, if you mean Java sources, the comments are there, and the model should be able to visualize them.
And then I could generate the Java as well, but without comments, then the comments would be lost.
No, it will not. No, from these models that you import from Java, you've got read-only models that are not part of the generation process. They are only for allowing you to refer to them.
Okay.
Can you parse the text just into base language? Because base language is a superset of Java, so you should be able to.
Yes, you're able to parse it,
and then
right?
do the refactoring in this way. Some nasty stuff that has to be done more involved.
Yeah, you could do
and
that.
And then just spit it out as Java again.
Yeah, you could do that, right?
Was that what you?
Destroy something somehow because.
Yeah, but was that what you were asking? Yeah. So I suppose that perhaps this is doable, but it would just mess up the formatting and leave it a little bit, but it would be no big deal.
But you will lose a lot of formatting, I guess.
Yes, but that's all.
Some extra braces and comments and some nuances in
Yeah.
textual art and so on. But definitely it looks like a useful thing. So can I start using MPS for my projects, let's say for free for non-commercial projects?
I mean, all right. Well, the licensing. Well, MPS is open source. It's Apache 2 license, so yeah, you can use it. The way we try to monetize this project is by providing support contracts for customers who want to kind of rely on JetBrains that MPS will evolve and will be fixing bugs. We'll do trainings and consultancy. Yeah, but the tool itself is free, so that's why we have so many academic usages. We've got people at the universities doing research. We've got diploma thesis at the Charles University here, for example. The Frege one I mentioned, that's like one of. Well, we've got 3 already done, and then we've got 2 more running. We've got researchers doing research with MPS. We had a guy from Norway coming down to Prague for 3 months this year just to learn MPS properly so that he can do his research. So yeah, that's a tool that you can use for academic, open source, or commercial projects freely.
So also the base languages or base language 2, the normal language is free.
Yeah. All you've seen here. I mean, we don't.
How many are there, or which languages?
Which languages? Well, we've got Java and XML. Then partners from Germany, they've got C, also open sourced. Then there's JavaScript and C# at GitHub, but not really production ready. These are like intermediate. well, the JavaScript is in slightly better shape than C#, actually. Let me think so I don't forget. There's R implementation, the statistical language R, right? But that one is not open source as far as I know. That's some company in the US who built a tool that they sell, I think, on top of MPS for editing the R programming language. Yes, and actually one of the diploma theses that finished this year was about automatically converting grammars that you have for any programming language, like C, for example, into the MPS definition. So you feed, on one end, you feed it the grammar definition, and on the other end, you should get a language, MPS language definition. So yeah, you get that, but it's not perfect. I mean, the editor is very basic. The structure is there, but the editor is not very very intuitive. You would have to do a lot of work, manual work, to make the editor better. Yeah, as far as I know, there's also some implementation of Python going on in some company. Yeah, okay.
This language you use to define languages, is it itself written in?
The languages that you use to define languages are defined in MPS themselves, right? Yes, so it's bootstrapped. This way.
You actually develop MPS in MPS?
Yes, we do. Yes, there's some Java, code that we have, but most of it is developed in MPS itself.
When you say you have a JavaScript, Python, does it mean that it generates Python code and JavaScript code, or there is also the structure editing for generating JavaScript applications?
There is, I mean, you can edit JavaScript code in MPS, but it's projectional editor, but then you generate it into textual JavaScript. Yeah, so you've got just like for Java. So ultimately, this should be the same scenario. You edit the language as you know it. So Python, you would edit Python, and then it would translate into textual Python sources. Yes.
But my point was that you can get, now you run on top of Java, then it's on top of JVM and Java.
All right.
So you can run on top of, I don't know, web browser.
Well, that is the long-term goal, but we're not there, right? The dependency on running on Java is very strong in MPS, so you can't really run it on different platform. I mean, the MPS itself, the tool is Java-based, so that wouldn't work at the moment. We're thinking about the web as target platform, because that would certainly fit many needs of the customers, because the web deployment, that's something they frequently want. And we don't have that yet. We have some prototypes which are currently done outside of MPS, and then based on the experience there, we might do changes to MPS to allow this. So you would create languages probably the same way you do, but then you would deploy them to some web application. So you would get like web text area where you can edit projectionally.
Yeah, but one could imagine some scenario where you would like some transpiler from base language, which is essentially Java, into JavaScript, and then you just write a lot of wrappers for Swing that would sort of implement or emulate it in SVG, for example,
right.
Elements in the page, and you could bootstrap the transition in this way, and then you'd get something that would sort of work, perhaps.
Perhaps, yes. We're actually...
Build a JVM in JavaScript.
Okay, yeah.
Yeah, that would be the too easy.
Yeah, we currently have already a library that allows us to do projectional editing on the web, right? But it's not bound to MPS. You have to manually, you have to define your languages outside of MPS. It's really a prototype tool. I think I'll try if it is available. Okay, maybe not.
Why? Analyzer or analyzer?
Yeah, you're right. And I never know the URL. No, that's definitely not it.
Just type it into Google.
Yeah, I thought I know the URL, but oh yeah, here we go. That's our application for data analysis based on this web-based projectional editor. So not really MPS, but maybe something that will employ an MPS at some point. You might play with this. Maybe you find it interesting. So it's some sort of data analysis tool where you've got a language that you through which you defined your data, well, not really transformation, but the queries that you want to visualize. And the editor is projectional. So it's not text-based that will be parsed somewhere. It is projectional. I think it also does things like code completion there. Yeah, so it has some basic editing capabilities. It has this little, you know, how would you call it? Like button tool or toolbar, in editor toolbar where you can invoke some common actions right from the editor. So this is some demonstration of where we've got a team that's playing with this and trying to come up with a product that would somehow allow you to do data analysis on the web. So here you can play with this. But I don't think this has been updated for like a year, so maybe they're now doing something. I'm not sure they're updating really this thing. But it might give you some idea. So we've got a library that allows you to do IDE on the web, where you've got code completion and the editor and layout and navigation, that all works. But it's not MPS generated at the moment. Yes.
When you define the range iteration, or what was it called, the concept, you reference the statement concept.
Mm-hmm.
Can you show the source for this statement concept?
Yes. Okay, so range iterator was defined. So here is range iterator, and well, here we have a statement because we extend statement, right? Statement comes from base language. And it only has an alias and no children, so that's basically the empty line thing. And it itself extends base concept, which is like the object in our language definition language. So it's the common super concept for concepts, and it inherits some qualities from these concept interfaces, as we call them, but which seem to be more like marker interfaces here. Yeah, definitely these three are just marker interfaces.
So it's something like hard-coded down there somewhere?
Well, because I'm extending base language, so then I'm hooking in the elements in that language.
Okay, and I don't know the base language. How is it defined?
Yeah. All right. Well, all right. Well, base language is like copy of Java. So whatever is in Java, we had to mimic in the definition of base language. So this is sort of a counterpart of Java's empty line or statement. All right? And Java defines a while loop. And we had to define a while loop ourselves as well. So this
that reference is something called abstract loop
yes,
statements.
yeah.
So what is it?
All right, well, that's a common super concept for all looping concepts, like for loop, while loop, do while loop.
Maybe the statement, it would be sort of natural if statement itself were abstract. So
Right.
It's not abstract because if you think about some simplest statement possible, then you can answer that question and say, well, that would be an empty statement. So for that reason, the statement itself is not abstract.
Mm-hmm.
It's sort of just a coincidence that there is some very simple statement handy that you can use as the default one.
Yeah, okay.
But it would be more natural, in my opinion, if it were abstract, because there are many statements.
Right. Yeah, actually, this is how I did it for the robot example. Well, in the robot example, the empty line is represented by a concept called empty line. I'll close this window here. And we've got instead of statement, I mean, in Java you have statement, here I have abstract command, which is really abstract concept, which represents all statements that there are, and it itself is abstract, so you can't use it directly. And for empty line, I've got a new concept, which is a case of abstract command, which is no longer abstract, it's actually final, so you can't create subconcept, and this will represent empty lines.
So this will be sort of more, perhaps, I don't know, a little bit more like
Proper.
yeah.
Yeah.
But the thing is that statement is sort of empty because it's a common ancestor of many other more concrete statements.
Yeah, exactly.
And we can have a look at them. Could you find all descendants of statements?
Yeah, you can visualize the hierarchy here. So here are all the descendants, I mean subconcepts of statements. Yeah, well, that's quite a lot of them. All different statements.
And then you can, of course, you can have a look at the generators for all those concepts that define what they are in Java.
Yeah.
Since we were extending Java language,
Yeah.
one extension, it was just one example of how extension of languages works in MPS.
Mm-hmm. Yeah, because the language I decided to extend is base language. It has statement, and that's exactly the guy I wanna extend, because statement is in base language or in Java, it is the concept used for anything that can be in a body of a method. If I look at the definition of a method declaration, so method declaration, well, static method declaration is a method declaration, it's a base method declaration, and here it defines body, which is a statement list. So each method has a body, which is statement list, and statement list has a collection of statements. So if I want something to be part of body of a method, I have to declare it to be subconcept of statement. Pretty much the object-oriented approach, because I expect, well, statement list has a list of statements, so if I want something to be part of statement list, there has to be a statement or a subconcept of statement. Yeah.
Of course, there's language for describing concepts, which is described in itself.
Yeah. Yeah, and then it becomes very difficult, to get your head around this, because now you go from the programming into meta programming into meta programming, where you define how
It's all the same.
Yeah.
That's the nice.
Yeah.
There's no meta.
Yeah, you basically loop through the meta level.
And we can actually show that point.
Yeah, right. But there was a question there, so I don't want to interrupt you.
It's much more basic. I was asking if you could rewrite this sleep sort in MPS.
Sorry, if I could rewrite what?
This sleep sort in MPS.
You mean, yeah, sure. But why would you want me to do that exercise? You mean just to see whether the editor is able to handle it?
Yeah, to see the way how different it is from plain Java.
Okay, well, the code should look pretty much the same. It's just I don't have all the shortcuts there. So, yeah, I have to iterate. I don't have the live template for iteration, I think, here. Although I could have defined it, but I don't have it. I mean, the language designers didn't provide it for me. So I would have to use, just go for loop, where we have a string args, right? I think it was this way. So now we need to parse it. So I would have to go integer parse int arg this guy, storing a variable value. Oh, what was that? Value. What else? We had that thread pool. So see, the completion is not that clever, right? I can't really type just name of a method and expect it to search for it everywhere. So I have to remember the class executors to get me new fixed thread pool.
So is it actually less easy to write Java in MPS?
I would say so, you know, because IntelliJ IDEA is really tuned for Java, while MPS is, first, it's general. It doesn't know actually about Java as such. And the language author that created this Java implementation would have to mimic the all functionality that IntelliJ IDEA has. But IntelliJ IDEA has like 15 developers working on the Java support, while MPS team has only one guy doing the base language support, right? Me. So I would have to implement that.
Actually, that's interesting because this one guy can be captured with these 15 guys in Java.
Well, no. I mean, there's a lot of stuff in IntelliJ IDEA. Right? There's really a ton of new features, like this postfix notation or whatever they call it, right? Where you can just at the end of the line do .if, and it will translate it into if statement or something. You know, there are many cool features in IDEA that MPS doesn't have.
It's all doable.
It's doable. I mean, yes, there's nothing in principle that would prevent you from doing the same things, but it's,
IDEA obviously has many years ahead of MPS, I suppose. But if you start afresh and you put 15 developers rewriting IDEA in Java and do that in MPS, would you catch up to them? Would you lead them?
wow, that's an interesting idea. I don't know. I would claim that maybe, yes. Because actually, we use domain-specific languages to define languages. So if the idea of having domain-specific languages is valid, if you know the claim that domain-specific languages makes you more productive, then definitely we should beat them because they're using plain Java to define the features in IntelliJ IDEA, while we have domain-specific languages to define the features in MPS. So maybe we could be more productive.
And specific, I think that defining your own macros like this times thing, it can boost the productivity. Often you just can't help repeating a lot of stuff in Java.
Yeah.
And there's no way to, you can define a method or whatever, but it's ugly. I think defining those new bits of language could really help programmers a lot.
Yeah.
Even though the IDE itself is not so clever yet, the possibility to cleanse the language could help a lot.
Yeah, all right. Yeah, I agree. And actually, the thing like, this being able to insert the public static void main method by this same shortcut you do it in IntelliJ IDEA, well, we have it, right? Sorry? Yeah, it is. Public static void main. Now I type M and it's done. I don't even wait for you having to do control space or tab or something. Because there's nothing else that would start within this crazy way. So yeah, public static void main. As soon as you type it, it is there. Same for system out print line. But nothing for the iteration or the others, unfortunately. Yeah. Maybe I should add them. Only for demonstration purposes, it would help, right? If I had it, because then I could demonstrate you can be as same powerful as you are in IntelliJ IDEA in MPS. So I could do the same sleep sort here. So maybe I could tune it to sleep sort. Yes?
Could you estimate how hard it is to create base language?
Very hard, very difficult. Yes. Right. MPS is the second oldest project at JetBrains. In the first prototype I saw in 2003 when I joined JetBrains. So at my interview, I was shown this project already, so I know it existed. IntelliJ IDEA is from the year 2000. In 2003, there was a prototype of MPS already before any other project was created. ReSharper, Team City, that's much younger. Oh, well, not much younger, but a couple of years younger than MPS. And obviously, in the year 2000, there already was some base language implementation there, because otherwise the project couldn't be done. So if you count that, then it's quite a lot of years of evolution. but we've made a lot of mistakes along the way. So I would say that, in one person, base language, 5 years to get to where it is at the moment. To get some, well, maybe I'm too pessimistic. Maybe I am. Yeah. But with all the knowledge and now having, some, I think much shorter. In 1 year you can have something pretty usable. I think so. Especially, oh yeah, you're very optimistic then. Yeah, it could be.
He has done such things.
Oh really? But base language or Java, they have a lot of irregularities.
Maybe you're right. If you want to mimic a language that is originally text-based and text-designed, yes, you are probably right. But if you want to create a new language with this new technology, you will be very fast.
Yeah. Yeah, that's right.
You can leverage all the good things, and you are free from the textual heritage. And it is like a history about steam engine versus electric motor. If you know the story, originally when steam engine came in, there were factories, and in the center of the factory there was steam engine, and all the other power-dependent machines were connected to it. And when electric motors came, so what they did, they just threw out the steam engine and put their big one electric motor in the center. So, and it took years or 20 years while the new technology started to use it, and when they could use the power of the technology. I think it's the same thing.
Mm-hmm. That's a very good analogy.
You mean that instead of using as many engines as you need, and the places where you need them?
The best thing what to do is to start to create a new language that creates all heritage to the text.
Mm-hmm.
And just show the power when it is really based on that, not just limit.
Right, I agree. The biggest problem in base language implementation is the type system, generics. So this is where the implementation becomes very difficult, very complicated, because there are many irregularities. How you've got types which are boxed types, and you've got integer and int, and to support all these cases, it takes considerable effort to implement it. Having the default structure is fine. The editor and text gen, it can actually be done automatically from the grammar file, but then a lot of effort goes into the fluent editing thing, so that you can type plus and multiply, and it just smoothly continues. And then the type system, that is very complex.
Perhaps if you do that for one language, then you arrive at certain tools that help you do exactly this sort of stuff, like this fluency has certain patterns. The code that implements the fluency has certain patterns.
Mm-hmm.
And if you abstract that into some, not even library, you could abstract it into some new constructs in base language or so. Then if you implement another language, you would be probably much quicker, because you'd have all those handy stuff.
Yeah. And that is actually...
allow you to do that.
Yeah, we're actually planning to have it in the next version of MPS. So when you define your editor, then, it's still not decided how exactly this will be done. Well, we'll take inspiration from Embedder, which is, the guys in Germany, they created the C implementation, and they have this. So they have cells where you define exactly like grammar cells. So it's not only that you define in the editor, just for illustration, bring up the editor definition as soon as I find it. Oh yeah, I think it was here. Range iterator, editor. So not only you would define the static layout of the editor, but you would associate with it, you would say like, maybe here I would say word called, whatever, could be final, whatever, even though it doesn't make sense here, right? But you can have something like final, and you would say, well, this is actually a flag. And then the flag has certain behavior. You can type it at the beginning of a line, and then that would mean you want to possibly make something out of this. So, make something that can be final, can follow. You might want to delete that final because that's optional. Sometimes it is visible, sometimes this is final, sometimes not. And all that logic will be just part of that cell. So you would say, well, the word should be final, and it should be a flag cell. So special type of cell that is flag. So it has some runtime behavior associated.
Also priorities, operators,
Yeah, also that.
and new settings is great.
Yeah.
So how do you deal with that? For example, if you have expression with different operators, you have to write your own Java code that contains all the logic for priorities of operators.
Yeah, each operator declares the priority. There's some priority list, so you declare the number where you fit.
You have to do it in Java.
Sorry, you have to.
Encode the rules for priorities, let's say, or does the templating language somehow help?
No, you have to when you implement your operator, when you define.
If you want to mimic Java operators with their priorities.
Yeah, so you have to, in plus expression, you have to define your priority, get priority. So you see, so each concept, like plus expression, for example, they have all expressions. They have their own. They can have methods as well. We call it behavior. So each concept can have methods as well, and inherit and override methods. So there's one method that it's taken from binary operation, and that's called get priority. And here you say, well, how your priority, and then the editors in base language will consider the priority whenever you make a change to the AST, and will do the reshuffling based on these priorities. So when you define your own operator, then you have to say how the priority. Yes.
Question: if you mentioned that during the MPS development, sorry, not the MPS, but the Utrecht development of Utrecht plugin with MPS,
Mm-hmm.
you learned a lot about designing and building domain-specific languages. Can you share some insights? Because what I see here is maybe this like a steam engine versus electric motor, because you start with the Baroque language. I mean, like it's really Baroque with all the ornaments,
Mm-hmm.
while people building something simple like 20th century architecture, just straight lines, no ornaments, so something really simple. And it reminded me of another project by Alan Kay. He started the Viewpoint Institute, and their goal was to rebuild the whole computer stack in 20,000 lines of code. And their main advantage was creating DSLs for graphic stack. They were able to implement the graphic library with all the aliasing and so on, only in 500 lines.
Mm-hmm.
By simplifying. So this looks like a Baroque building or the Chinese characters. But
So you mean Java thing, right? Or
yeah, so maybe
Yeah.
it's because you started with Java, maybe you need something
yeah.
simple, to make a math, understand, to build a high concept and apply them, and not to
It's like Lisp that has all the
play
braces
with
and
the
Yeah.
hierarchies and all this fancy stuff, which isn't essential.
Well, on the other hand, when it's able to handle Java, I guess it can handle anything.
Yes.
Java syntax, because it's like all these rules about
Yeah.
text
You spent 5 years to make a prototype and learn how to do it.
Sorry, you what? You said
Well, if you want to implement Java,
right.
as you said,
Mm-hmm.
useful, but you spend 5 years, and if you start with something simple, you
Yeah.
can spend these 5 years making
Yeah.
so many experiments which push you forward much faster than with building Java.
Right. The Java well, having Java in MPS is essential because you want to target Java, right? So you have to have that language implemented in MPS so that you can do robot. The robot example, for example, where is it? Too many windows open. Oh, that was the one. So in order to build this robot, to be able to code in this robot, I still need base language to be there because this is my target. Right? I want to, from this robot script, where there's no Java, I don't need to know about Java. Still, when I hit compile, it will generate this Java class or set of classes that then Java compiler can compile. So we can't live in a vacuum. So we'll still need some baroque language to be implemented in MPS as target. But the idea obviously is not to code in Java in MPS, only switch IntelliJ IDEA for MPS. That wouldn't really give you many benefits. So the idea is that you would have high-level languages, and then you don't really care what gets generated from this. Now the trouble is, as I said at the very beginning, we were all born when programming had already been existing for quite a few years, and it's difficult to imagine alternative approaches to programming. It's just, I suffer quite a lot from, not being able to see how things could be done differently. So when people came to me telling me about this, gesture recognition for programming, it seemed like a crazy idea at first. But then later I realized, why not? Could be interesting. How about touch devices, for example, right? If you've got a tablet, can you write code? Not very conveniently. But if you've got some tool like this with a palette of, if statement, for loop, maybe for some simpler DSL, then you would just click on the panel here and it would insert it for you in the code. So, there are many options. And I believe that, the programming languages in the not so distant future will be very different, or hopefully will be different from these languages like Java. Maybe not for everyone. I still believe there's a lot of room for Java programmers, C programmers, because the infrastructure actually needs someone who understands that infrastructure. And after all, if you create fancy DSL, you need a good Java programmer or Java programmers to create that generator that will translate that into Java. You need really good Java skills to create that generator. So it's just that you don't have to have Java programmers for every single piece of business logic that you want to implement.
Yeah, but you use the alternative visualizations in your development.
Development of what? You mean of MPS?
Yes, because you should be using your own advantage.
Yeah, we are. Yeah, sure, we are.
You're planning to catch up with the 15-member project.
Yeah.
Running along, so you have to be leveraging.
Yeah. Well, actually, for each single aspect here, we've got a set of DSLs to define them. You've already seen the DSL that we use to describe the concept, right? That's an object-oriented way where there's some inheritance. So it resembles object-oriented languages. But when you
something that's not text-based.
not text-based. No, none of these is non-text-based at the moment. That's because the non-textual notations have been added to MPS like a year ago or a year and a half ago, when this had already been invented. We did not replace them with anything that would be graphical. And I'm not even sure that it would be beneficial for most of these.
No, that's the question, because if you're staying on the text level, you can use something like a list macro.
Mm-hmm.
You might be better off. Yeah, but because you have the simple language and you have the same language for generating the construct in your language.
Yeah.
You don't have to learn new stuff just to build on it. You can make your own DSL, but you'll be limited to staying text-based. So if you are working on something better, maybe you should be using some of that, because if you are not, that it may be of no value, but very limited value for anyone.
I suppose the problem is that you use a huge budget to write all these graphical design pieces.
No, I'm not saying that everything should have been written that way, but I'm asking if there is something that would be clearly beneficial to
Probably, yeah, for language definition, it really depends on the task. And I think the language definition task is not really suitable for non-textual notations, like can't imagine.
One should discriminate between the notation, like it's a presentation, and the representation. So still it's very beneficial if you have a non-textual representation, because then you can extend the language for defining languages itself in a very easy manner without worrying about like keyword clashing and that. So it's very important. So in order to get this extensibility, you have to have this, you do not have to have, but it's very nice to have an abstract representation, a non-textual one. And then a separate thing is whether you like present it on the screen in a way that we are all used to like read with our eyes. And that's a separate question. But this should be like, there is already a huge benefit in having a projectional editor, even if you still stick to textual like presentation.
Yeah,
What do you think? I think
if you are having the unliteral, I mean, it would be so hard to do it in
yes,
a parser.
but it's still presented like a text, but you get the benefits of the non-textual thing underneath.
There's a general conclusion. It's like the motor steam engine. Both were rotating, but quite differently and different scales and so on. And this is a nuance and confusion between representation and presentation.
Yes,
that's exactly what he said. It is not notation versus resistance. So now resistance and notation is the same thing, and that's the not separated concerns. That's the problem with textual languages, that these two concerns are together, and you cannot pull them apart because it is so the custom, it is heritage, it is just everywhere, and you cannot get rid of it. And that's the problem if you want it. And then the second point is the composability, as you said, and it is pretty hard to make textual languages composable. That's and especially if the author of the language is different. You want to scale it on more authors. And here you can have ambiguity. You can have more textual notation side by side. See, they can visually be the same or textually the same, but there is no concept. And if you want, you can fix it and you can change it, but the source will remain the same. So this is like the rotating machine. It's just different, and you can separate it at least at last with this approach.
Yeah,
It's very hard to explain someone who did not try.
Yeah, the main advantage of projectional editing, well, I named three, right, during the presentation. The ability to use rich notations, tables, and diagrams, but they're just one of the benefits, which might not be really useful maybe for language definition. Or, well, in fact, we were thinking about diagrams to visualize the concept hierarchy. Well, that might be useful. You click on a statement, and you see statement and the graph of subconcepts somehow visually, and you could enter, maybe some, parts of definition in that sort of diagramming language. But that's only one benefit. The second benefit is that you can look at your code in different projections. Well, and the third is that you can combine languages. And that's probably the biggest benefit, because you can really, you don't have to think about, I've got this language, but how do I get some part of that language into it? Like, robot Karel, good, but how do I make some part of it Java? How difficult is that? Well, I've just done it, right, during the discussion here. So now I have Java for loop down here, and I can do system out print line down there, and I've got it part of my robot Karel. I've placed some part of piece of Java code in there. Now, obviously, no semantics so far, but now I would go to the generator, and I would say, how this should be translated into something meaningful. So I can combine languages at will, and nothing prevents me from doing so. There's never name collision between things from different language. So that's also a benefit. So yes, we definitely benefit from this ability in the language definition languages. So if you define, for example, if you define the type system, so this is a very specific language. Let me just check where. All right, that's better done in a different example. Yeah, the range iterator. So you see, this is a very specific language, only for type comparison or for defining type inference rules, which the essential part of it are these equations where you put some parts of your code in a relationship in terms of the type, but you can mix and match it with languages like with base language, for example, or you can mix and match it with collections and closures and any other language that you feel that you find appropriate in there that you need. So we definitely leverage that aspect of projectional editing, not necessarily the alternative notation thing. I mean the diagramming notation, but at least in.
How is this different from writing macros in a list language?
And not much. I mean, list macros are very powerful.
I could answer this question because it is a lot different. And one of the try to implement a macro that will check your size.
Oh.
In editor, will provide you proper intelligence. Try that. No way. And this is far more than macro. This is like macro is again schema engine, and this is something very different because it is only one aspect. Is the macro, is the generator. You have concepts and you generate something from that. But around that, you have more aspects like type system, constraints, data flow.
Yeah.
What else?
Well, intentions, for example.
And you can create your own aspects. So that's completely different story. And macro are like macro is
Macro is a program. Programming the same language as the target language.
what I'm saying is about what you will get from macro when you want users to use the macro. I mean, you cannot define intelligence for the macro. You cannot define type system for the macro. You cannot define data form for it. It is just code generation aspect and nothing more. That's it. Macro is great. It's perfect. But this is far more. This is macro on service.
Right.
It's not about the output, it's about user experience. How you use it, how you program it.
Sorry, I'm not too sure because you can imagine to have a library that you can use point macro, where you have the part of the macro that generates the code and the part that checks the code and does the stack checking.
But you will compile how?
Sorry to interrupt.
Yes,
I have one proposition. I have one proposition. This is just exactly correct theme to have a discussion with the beer in your hand.
Yes.
And within your hand. So, what do you think? We can stop here. Maybe in future we can continue with some MPS too. But I would propose to now, it's already 2.5 hours.
Wow. Okay. Well, yes.
The longest presentation ever, right?
Actually, yes, it was, right? And most questions, which is most enjoyable. I really, you guys seem like really you are into investigating things, which I really appreciate because that really makes me feel like, yes, this is definitely an area that is interesting for many people, and there are questions, people that, and I like people questioning how we do things, right? Because that's only the chance for us to improve, and at least improve the messaging and maybe also improve the tool itself. So I'm very grateful for this. So yeah, let's continue with beers in our hands. And yeah, thanks you for coming here. I really enjoyed this presentation.